Have some simplifying today. We are looking at an interesting problem because on the top of the fraction we have this whole statement being raised to a fraction exponent of 1/2, where the bottom statement is being raised to a fraction exponent of with a negative and a different denominator of 1/3. So we have 1/2, 1/3, this being negative. So this is really testing our knowledge of a couple things. First, it's testing our knowledge of what does this mean? What does a fraction exponent of 1/2 mean? What does a fraction exponent of 1/3 mean? It's testing our knowledge of what do I do with this negative exponent. And then down the line, like a couple moves down the line, we're going to have to worry about variables of the same base and division or potential multiplication. So we have a lot going on here. We have to understand this. Now, the way the question is written, I want to write something out. If I had this, x to the 7th over x to the 5th, y to the 3rd over y, something like that. These two problems, this one and this one, these are not the same problems. Because in this problem here, or even if let me just raise this whole thing. Let me get rid of these. So let me just raise this whole thing to the 5th. Just make up an exponent. This problem, I have this whole entire fraction here being raised to an exponent. So I can actually simplify this, x to the 7th over x to the 5th, dividing by the same base. I subtract. I could do that and then raise everything to the power. But here on the problem that we're given, I don't have that because it's this whole set of parentheses being raised to this 1/2. This whole set of parentheses being raised to this negative 1/3. Those are different exponents. So therefore, we can't just put it all under the same exponent, under the same parentheses raised to that same exponent because they're different. So I have to deal with everything separately. So that's just like a piece of information that we're really making sure we understand there. So here's what I'm going to do. I'm going to, I'm torn between two potential steps here. Let's talk about the fraction exponent. Let's just talk about the top first. Let's just deal with this. When I have a fraction exponent such as 1/2, this is what this means. So if I have x to the 1/2, this denominator indicates what the index is going to be on the radical. So the 1/2 is going to be the square root of x. If I had x to the 1/3, that's going to be the cube root of x. If I had x to the 1/4, that's going to be the fourth root of x, and so on. So the denominator tells us the root, the square root, the cube root, the fourth root, whatever that is. That's what the denominator tells us. So on the top here of our fraction, we have everything being raised to the 1/2. That means I'm going to be taking the square root of every single thing. And you can rewrite this out. You can take 9, and this is 9 to the first, so this would be 9 to the 1 times 1/2, x to the 6 times 1/2. Sorry, that was... pen kind of slipped out of my hand. 6 times 1/2, y to the 4 times 1/2. You could do that also. That's another route. Or you can just understand this is the square root of everything. Now I'm going to erase this. I don't want too much information on my screen here. Now I do want to point out, if you just say, well, everything's being taken to the square root. So I have the square root of 9 times the square root of x to the 6 times the square root of y to the 4th times the square root of z to the 8th. What you would end up doing is you would end up just going right back to this form that I have written here, like right down there. Like you'd end up just doing that because this would be, the square root of 9 is 3. And then this would be x to the 6 over 2. Like you would just think, well, if I'm going to simplify this, I have to do 6 divided by 2, y to the 4 over 2, z to the 8 over 2, which I forgot to, 8 times 1/2. So you'd end up anyway just doing the 6 divided by 2, 4 divided by 2, 8 divided by 2, but it doesn't matter. So we're going to have 9 to the 1/2, which is the square root of 9, which is 3. So we get 3 there. So we get 3. X, 6 over 2 is 3. 6 times 1/2, 6 divided by 2 is 3. Y is 4 times 1 divided by 2, which is 2, 4 over 2. And then z to the 8 divided by 2 is 4. So we get z to the 8th. Great. Took care of the top. Just understanding those exponent rules of 1/2 is the square root, so that's 1/2, and you could just simplify it there. Now on the bottom, I have this whole statement divided by 8, x to the 6th, y to the 12th, z to the 24th being raised to the negative 1/3. So here's what I want to do now. I'm going to take this entire statement and I'm going to move it to the top because it's a negative, so I can move it up to the top. Not going to really help us out in simplifying as of right now, but just cleaning this up as much as possible. So 3x to the third y squared, z to the fourth, times 8x to the sixth, y to the 12th, z to the 24th, all raised to the positive 1/3. Now we can do the same thing though, as I did before with that 1/2. Now I can just think, well, I have 8 to the 1/3, x to the 6 times the third, and so on. So I'll have 8, I'll have the cube root of 8, I'll have the cube root of x to the 6th, I'll have the cube root of y to the 12th, I'll have the cube root of z to the 24th, which then just cleans up to being, and I'm just going to deal with this now. So I'm just going to deal with this. So this is going to be the cube root of 8 is 2, so this will be 2. X to the 6 over 3, because this becomes x to the 6 over 3, which is going to be squared, so x squared, so 2x squared. Y to the 12 over 3, which is going to be y to the 4th, 12 divided by 3 is 4. And then z to the 24 over 3. 24 divided by 3 is 8. So I end up with all of that. So I have 3x to the third, y squared, z to the 4th, being multiplied by 2, x squared, y to the 4th, z to the 8th. With the problem it is the way it is now, I don't have I don't know if I want that line there. I'm just going to try to separate it out, but I don't know, maybe that looks like a fraction sign. I don't have any more division. Like, I don't have the division of the same base. Now what I have is multiplication. I have this first parentheses here times this parentheses there. So it's going to be 3 times 2, which is 6. And then I'm multiplying by the same base. When I'm multiplying by the same base, what I want to do is add the exponents. Because if you think about it like this, so x to the third is x times x times x. X squared is x times x. So if I'm doing x to the third times x to the second, I'm multiplying all these x's together. How many x's do I have? I have x to the fifth. 1 plus 1 plus 1 plus 1 plus 1. Multiplication of the same base. Add the exponents. All the way across, you get x to the fifth. 3 plus 2 is 5. So it's x to the fifth. So this is x to the 3 plus 2, x to the fifth. And what do we have for the y? So y to the second times y to the fourth, multiplication of the same base. We add the exponents. Y to the 2 plus 4 is 6. So y to the 6. And then we have also z to the fourth times z to the eighth. Z to the 4 plus 8 is 12. So we end up with z to the 12th. Main part of this problem is just that initial, what do we do with that square, that 1/2, what do we do with that 1/3, what do we do with that negative exponent, and then it just comes down to knowing your rules. What do I do when I'm multiplying by the same base? If it was a division question, what would we do when we were dividing by the same base? We subtract, but here we ended up with the multiplication, and I know on the surface, like you thought, like maybe when we got to here, like this step right here, you thought like, oh, I'm probably going to be doing some sort of division of the same base because I see we have some numbers on top, some numbers on bottom, but this negative exponent forces us to move this up, and then we end up with this multiplication of the same base scenario. So that's a really good problem to make sure we understand those rules.